Hi you guys, welcome to skill 19, or 17, sorry. We're going to do dividing polynomials. So polynomial is just an expression that has any sort of algebraic expression. So like 2x is considered a polynomial, so like 2x plus, that is considered dividing a polynomial. So let's just go ahead and review before we get started our exponent rules. So if I have something of the same base divided by each other, my exponents can be subtracted. So x to the third over x squared equals x to the 3 minus 1, or just x. If I had x squared over x to the third, that'd be x to the 2 minus 3, x to the negative 1, or just 1 over x. So when we have something to a negative exponent, we make it positive by putting it on the other side of the fraction bar. Or you can think of this, I had 2 x's on top, 3 x's on the bottom. 2 of them canceled out, and I'm left with 1 on the bottom. So let's go start and try this one. I have 9x to the third. It's asking me to divide by negative 3x. I'm going to go ahead and do each of these as separate terms. I end up with x squared. 9 divided by negative 3 is negative 3. 2 minus 1. I have 1x on top. 6 divided by 3 is negative 2. 12 divided by negative 3 is negative 4. 1 minus 1 is no x's. So that's what that would equal. So we're going to do the first one of these together, and then you guys can do the second one on your own. So I'm going to do each of these aspects is divided by negative 4 x to the third. So each of these terms. So I'm just rewriting it. I cannot simplify this other than my negative 1 divided by negative 1 is a positive 1. 2 x's on the bottom, 4 u's on the top. This becomes negative 3. 2 x's on the top, 4 u's on the top. 2 x's on the top, 4 u's on the top. Becomes a positive 5. 5 minus 3, 2 x's. 1 minus 2, a negative 1, so I'm going to have 1 u on the bottom. Go ahead and try this bottom problem on your own. It would stay negative. I would end up with 5 x's. It would stay negative. I'd end up with 4 x's. It would be negative. I'd end up with 1x. Okay. The last aspect of dividing that we need to remember is synthetic division. So this graph over here kind of shows us what it looks like, but I'm going to walk us through it. But we're doing this problem. This is a problem that we're starting with. So when you start with synthetic division, I have an x to the third, x squared, an x, and a constant. So I start at my highest, go all the way down. And then I'm going to put the coefficient underneath it. So 2, -5, -1, and my constant is 3. Say I was missing a coefficient, I would put a 0. If it does not have one, I'd put a 0. Then we're going to find what I call a magic number. So I'm going to set my x plus 3 equal to 0. So my magic number is going to be a -3. So we're going to keep that in mind. I bring down my 2, this magic number. The only way to get this back over is to times it by a -3. I'm going to do a different color. Times by a -3. So I end up with a -6. I add down, I end up with a -11. Now I times by -3. That ends up with 33. I add down. That gives me a positive 32 times -3. -69, add down, 93. Whatever number is left is our remainder. So I have a 2, a -11, a 32, and a -93. I bring all the powers down one, so it started as an x to the third, it's now an x squared, because technically, think about it, if I just had like 2x to the third divided by x, like just took the beginning part of this, I end up with 2x squared. This was an x to the third, x squared, now it's an x. This was an x, now it's a constant. My remainder I put over whatever I divided by, plus a -93. We're going to go ahead and practice this. If you need to watch other videos on this or study this example more or rewatch this example, go ahead and do that. However, when it gives it to you, it sets a lot of it up for us that we just have to fill in these numbers. So it got, I'm just going to highlight, it got all of these from here. It got this -3 from that. Times by 3, 12. I get a 2 times by -3, -6. Add down, get a -1. Times by -3, get a 3. Add down 3. Times by -3, add down, get a -2. So my numbers are 4, -4, -2, -1, 3. This is my remainder. So my remainder goes there. And then I would have labeled this x to the fourth, x to the third, x squared, constant. Oh, that's just an x, sorry. We don't have an x, so we put a 0 there. Guys, I'm going crazy. And now it goes down a power. So this used to be, this is now x squared. Or x to the third, now x squared, now x. Now a constant, and this is my remainder. So into this box, I would put our negative 4x to the third. And my remainder would be negative 2. So we're still going to do 2 more examples of this. So remember, this negative 1, this is what got us all of this. If it's helpful, I started with an x to the 4th, then I had an x squared. I had none, so I put a 0. An x and my constant. Dividing by x minus 4 is what got that 4 there. I bring down my negative 1 times 4 is negative 4. Add down is negative 4 times 4 is 16. Add down is 28. Oh, I made a mistake. This is negative 16. 4 times negative 4 is negative 16. Add down is I'm actually going to write all of these underneath. Then I end up with another negative 16 is negative 7. So this used to be an x to the third, now it's an x squared. This used to be an x squared, now it's an x. This used to be an x, now it's a constant. And then my remainder. So this would be a negative 7, and there would go x squared minus 4x minus 4. We're gonna do one more together. I encourage you guys to try this last one on your own. So remember, these numbers will get you that. If I were you, I would do the x to the third, x squared, x constant. This minus 2, if I set x minus 2 equal to 0, add 2, x would equal 2. Let's go ahead and pause and try this on your own from here. So in here would be our negative 1x squared plus 2x minus 4. And there would be a negative 6.